are you confused to understand the buzz technologies right now there in the market, right? Yes, I'm talking about artificial intelligence. I'm talking about machine learning. I'm talking about deep learning. I'm also talking about data science. So what is the underlying difference, right? And have you ever gone through the internet sources, right? And seen a lot of Venn diagrams explaining this, right? This always lead me to a confusion. So where to start from, right? And what to target. So let me give you the clear understanding of all these concepts through this video, so that if you are targeting your career in any of these fields, you should have a clear understanding in your mind. So see on my screen. So let's start with very famous Venn diagrams, which are there in the internet, right? Here, first skill they mention is hacking skill, right? I'm taking reference of the Venn diagram, which is very popular, right? To uh, give the understanding about what is required for learning, the technologies like machine learning and data science, right? So first, this one is the hacking skill. Second, here is the mathematics and statistics, right? And the third one is specialized knowledge, you can say. What does specialized knowledge means? Knowledge of a domain. And what does a domain mean? Area for which you are looking for solutions, right? So we can say finance is a domain, retail is a domain, right? What else? Energy is a domain, right? And there are lot many other domains where we education, you can also say education is one of the hot domain where you can say that a specialized knowledge is required. Now, based on these three skills and where these skills are intersecting, right? So-called Venn diagram, which we see, right? So this is called danger area. So you have hacking skills. So the literal meaning of hacking here is that you can hack a data which you have, right? And you have a skill to infer some information from that data, or to infer some pattern from that data, right? And you have a specialized knowledge of some field, like so you are working extensively in finance domain, right, for last so many years, and you have that skill that you can infer some information from that data, but still you cannot end up with finding any relevant business solutions if you have only these two skills, right? You infer and you have that knowledge of you know uh, that specific knowledge of that domain, right? So you are in danger zone as per this Venn diagram. I'm not saying that you are in danger zone, but what this Venn diagram talks about, right? This intersection is You have mathematics and statistical skill, right? And you have a specialized knowledge of some area, right? So this is called traditional research. So where what you are doing, so you are doing research on new, you can say new area or new area for that specialized knowledge, right? So and you are hypothetically thinking, so means you are doing some traditional research. So you have a researchive mind, and you want to research, you have a feeling of research, right? So you are trying to, but you are still, you are not giving any solution, right? So that's only that you are thinking, and you are trying to prove it, through your thesis or something else, right? So purely documented, you can say documented approach. And here, this intersection, right? This intersection is machine learning. So you have data, and you are statistically validating that data for future predictions, right? So there, the terms is called machine learning, this intersection. And the intersection of all these three things, this small portion, is called data science, right? So you have hacking skill for inferring data or getting some pattern from data. You have mathematical and statistical skills and specialized knowledge of a particular domain. And you're filled with all these skills. Then you can say that you have probably a very good chance of work chance of working as a data scientist, providing the business solutions for companies, right? But this is the Venn diagram, which is very popular, and this is nothing new, which I am talking about. This is the thing which is there in the internet, and you can find in many places, and you can see this Venn diagram. Explanation will be same, which I am right now I'm giving, right? And maybe some other information also there. But for me, I w- I do not view these technologies in this way. Rather, I view like this. So let's suppose you have a big goal to achieve, right? This is a goal to achieve, right? And to achieve that goal, there are some tools and techniques, right? So you can say technology to achieve that, right? And that technology I call ML, machine learning, right? And if you go deeper in this machine learning, right, even deeper, and try to mimic the human brain, then I would call it deep learning, right? And since we are performing all these things based on data, right? So data is always there. So I do it in this way. This is the science which is dealing with data, and this is called data science, right? So AI is a goal, correct? Now to achieve this, so when we say goal can be a driverless car, a driverless car, right? What can be the second goal? Take an example of a financial, industry, right? Complete, complete banking automation, complete banking automation, right? So this can be one goal. This can be the second goal, right? So this is the goal. So when I say complete banking automation, what does it mean actually? You have fraud detection. You have customer data management, right? You can have risk management. You can have product launch. You can have customer satisfaction. So, all right. So, all these are the function of a banking system, and you want everything to be automated. And you're with the minimal intervention of uh, minimal intervention of human, right? So every task of your banking system is performed, right? So it is in automation, right? So this is the goal to achieve, right? And to achieve this goal, we use this machine learning, which is first statistical analysis, statistical analysis of data, right? But this is very technical definition. I will not go in this with this, right? With this definition. For me, it is teaching machines. Teaching machines. So teaching machines means machines are like your servers, your laptop, your the thing which is taking input and providing you some output, right? Some data in the form of output. So you're teaching that. So what does teaching means here is, so this is very interesting to understand. Teaching machines. All right. So earlier, when we have input for a machine, there were some rules applied on that, and then an output was generated. So this was called rule-based system. So all of the software applications are based on this rule-based system, right? Rule-based. But what if a machine is capable to itself define rules for, you have trained that machine to define the rule for, the next coming set of data, right? So this is the reverse process. So you have, you do not have rules, right? You have only data, right? And the work of the machine is to identify rules, right? Identify rules. So when I say in previous example, let's suppose you are building a calculator, right? So you must be providing the operation to perform. So rule for operation is adding to numbers, is giving a sign of plus, right? So it is a rule. But what if you are training your machine that you have these input, right? And you have to decide at what time you have to add, at what time you have to multiply, at what time you have to subtract, right? So you are not ruling the machine itself, based on the data you have trained from historical information, your machine is itself deciding that what rule I need to apply. So that's called machine learning. So here one thing I told here, one important thing I told, that you need historical data, right? So for machine learning, historical data is important. Historical data is important, very important. So through this historical data, you train your machine. And yes, you use a lot of machine learning algorithm in that. Now your problems, remember, what is the problem? Fraud detection, customer satisfaction, customer data management, all these are the form of problems you have to solve, right? So your problem statement should fall in three categories for machine learning, right? Supervised, supervised, unsupervised, unsupervised, and reinforcement. All right. Supervised, unsupervised. So let me clear it once again. Okay. So machine learning problems can be divided into three parts, right? That is supervised, unsupervised, and reinforcement, right? But here, one thing to understand is what is supervised. So in supervised, there are two types of problems. One is classification and other is regression. Unsupervised is cluster based, and reinforcement is some portion of problem viewed as supervised and some is viewed as unsupervised, right? Now what is classification? Classification is your next set of data falls in which class, right? Which category. So for an example, if you launch a product, if you launch a fixed deposit product for a bank, so your customer will buy it or not buy it. These are two categories, right? Either your customer will buy it or not buy it, buy, not buy, right? So this is classification, right? Regression. If you launch a new product, fixed deposit, how much sale you are expecting from your, how much sale you are expecting from this new launch, right? So that's a value. So if you are predicting a value, then it's a regression problem. And if you are predicting a category, right, where it will fall, then it is classification problem. And clustering is you are making clusters based on few characteristics of data, right? So this is something you can say this is something which needs a very a relevant data set to showcase as an example. But let me give you a example that let's suppose you are in India, right? And based on the income group, age, and sex and education, you have made clusters of investments, right? Clusters of investments. So clusters can be high value investments, low value investments, and you can see medium value in medium value investments, right? And this can be no investments. So based on your data points or category of data that you have a high educated customer and his earning is the overall earning, monthly earning is good, and in last campaigns you have launched a new fixed deposit scheme, and the probability of that the investment of that person is high, so that will fall based on these many characteristics. It will fall in this high value investment cluster, right? So if any new person is coming into your system, banking system, after some time, what is the probability in which cluster this new person will belong to, right? These kind of problem we solve in unsupervised, uh, machine learning. And reinforcement is, mix and match of all these supervised and unsupervised learning. So driverless car can be one example of it, where few of the use cases are solved through supervised and few through unsupervised. Only one case, one use case, and it has application of both supervised and unsupervised, right? So then you can say it's a reinforcement kind of, example, right? So this is all about machine learning. Now, what is deep learning? Deep learning is basically a concept of mimicking human brain, right? So if you see human brain, there are neurons in the human brains, right? And these neurons store some information, right? Some incident events happened in past, right? And at this moment, if you want to take, you want to decide, you want to take a decision, right? So for a event or something which is happening with you, you want to decide that I should opt for it or not opt for it, right? So there, the human brain psychology is, it is it all the neurons participate with each other, and based on the influencing factors, or based on the information they have stored and the outcome of the events, and after weighing all of the possibilities, your mind talks to you and give you that you should decide on this way, right? So this is the capability of human being, and if you are applying the same concept in the machine learning, then it is called deep learning. And the thing which is mostly used in it is neural language processing, right? NLP, right? And multi-neural language processing also is there, right? So this is what we do in deep learning. And the machine learning algorithm for doing this deep learning are machine learning algorithms are k-means, right? Machine learning algorithms, k-means, historical means, and lot many, right? So this is the example and the explanation of deep learning, right? Now, what is data science? As I told in my picture, that AI is a goal, right? And ML is the one way to achieve it. And if you are going deeper, then deep learning, but everything is based on data. So data science is there. Now, what data science do? Data science is basically cleaning, visualizing, right? And statistical analysis, and finding relevant, hidden, you can say pattern in data, which are helpful for you to decide on that should I go for this business solution or not. Sometimes we do not apply machine learning, and we are not focusing on artificial intelligence to integrate that solution for a wider wisdom, right? For a wider vision, like artificial intelligence. Sometimes we just clarify from data that how our historical data is right, and right, is it the clean data through which we can you infer some information, or uh, you know is that data has some hidden patterns, so that it is motivating us to go and check for a business solution or a new launch for our product or anything else, right? So sometimes we do only these activities like visualization, cleaning data, and everything, statistical analysis, right, to make proper informed decision about from data, right? So that comes under data science. And when you are fixed with information, and you are sure that yes, this is the business problem which we need to address, and that business problem should be, we should train our machines so that for the futuristic data, uh, the decisions are, the machines are capable to take the decision, right? So then we go for the machine learning, right? And and in deeper in that, if we want to mimic the human brain, right, for our problem, then we go for deep learning. And when these solutions are built, so these are contributing to a bigger goal, that is artificial intelligence. So that's all about understanding, the all these technologies and where these technologies fits, right? What is the purpose, and how we are using it in a particular domain. So I have taken example of the finance domain, right? So that's all about in this lecture, and see you on my coming series of videos, where I'll explain more about the domain, where I'll explain more about the technology, right? And what should be the direction you should follow if you are trying to build your career in these technologies, right? See you there. Thank you so much for watching.